need representation beyond simple features, which are invariant to rotation, scaling, transformations, illumination, and in general, we want robust features for object scene categorization. So I want now specific objects itself in the video to be addressed. So this is a percentage challenge in front of image and video review. I would like to search for specific objects. Say all persons, all trains, all dancing shots where people dance together, or two people dance together. So I have requirements which are possibly I can describe it. Now I would like to retrieve such shots, and this level of search is next level possible. How do we do that? So the state of the art in this direction is if you are given an object of this sort, the representation of the object is with the help of backward words. That is, an object is represented with the help of a set of parts. What's the advantage now? This is a traditional representation in text domain, where a page is like Google represents a page as a bag of words. A bag of interesting words. A collection of a set of interesting words. Bag is a set. So here, we would like to represent this set with a help of few interesting object bags. Now this is the modern way of representing. What's the advantage? Now when this person turns the head, there is no problem. Because most of the parts will still be there. Now what can be the parts? The parts need not be just spatial decomposition or a patch of pixels. It could be a descriptor which is evaluated at interest points. And this is a classic way of building vocabularies, where if you are given an image with large number of descriptors, they are being descriptors at interest points. So these are some features. They have been clustered together to build a visual vocabulary. So the same point appearing in different forms is more like different way of writing the same word. So all such variations are grouped together, and this is called a visual word. A cluster of such interest points is called a visual word, and the representation of the image is now as a histogram of such visual words. Just the way a web page is represented as a histogram of words being presented, how many times each word is presented, is the way a web page is represented. What's the length of the representation? It is the vocabulary size of the language. Similarly, in the case of images, an image is represented as a histogram. So this we use for representing it. So there are two phases now. One is the offline phase, where the features are extracted from the examples and a code word or visual vocabulary is built. This is the vocabulary corresponding to images. Remember, it's not your text vocabulary. It's the visual vocabulary. And visual vocabulary classifiers are built on the visual vocabulary for design for objects and scenes. Now during the recognition phase, if you are given a new object, using this code word, a representation is built and a category or a decision is built. So we use this sort of a representation along with traditional features like zip or GIF. So these are the new types of features which are popular, which are replace this color, shape and texture to a certain extent, or to large extent. These are features which are now invariant, to many transformations, which are very robust and which are good to capture the visual content in a very powerful manner. Zip or GIF, etc. Now we use this for searching in track video. It's a video retrieval competition which is annually held worldwide, where the problem is, given 200 hours of video, it's more than 2 lakh shots. If they ask some questions, show me all bicycles. So it is not like, show me all green images. The question is, show me all bicycles. Retrieve all shots which contain bicycles. Retrieve all shots where two people are dancing together. Retrieve all shots where somebody is eating something. And there are very, very complex concepts. So what are the concepts where we failed was telephone. They asked the question, show me all photographs where people are using telephone instruments, big phone calls. What has happened? A lot of phone calls where I am not able to see anything. Anybody keeping hand like this is a phone call now. So phone instrument is not visible. If it is not visible, I don't know how to retrieve at this moment. So I will show you some examples of our video retrieval. So these are the examples of person riding bicycle. Is a question. And these are the results which are captured from this 200 hours of video data. At many places, people are riding bicycles in this 200 hours. And what we use is SDM classifier with intersection kernel and N4 feature. These are the results for cityscape. They want all cityscapes to be retrieved. So this is just to show the capability of the search engine. All cityscapes are retrieved. Which are like, this is a worldwide publication. So most of these videos have actually come from a Dutch television channel. So there are a lot of buildings what you see are like Dutch or European type buildings. Female face close-ups. So they want face, they want female face, they want that female face to be close-up. Close-up, they have a definition that at least, I think, 80% or 50% of the face, the image should be a face, etc. So these are examples of female face close-up. These are the top 25 results what our search engine will click or will return. There will be errors. If you carefully see images, some of them are made. These are the results which goes one more level up, where boat ship, we not only say that there is a boat ship there, we also say that where is the boat ship. So we not only do a classification, we also do a detection where we are able to draw a bounding box and say that okay, look at this, within this there is a boat or ship. Fortunately they have clubbed boat and ship together into one class. I don't know, I'm trying to distinguish between boat and ship. So it uses a random forest classifier with 4 features, sliding window and non-maximal suppression. This is another result with bus. There you can see some of them are wrong. For example, this red one, this looks like a front of a bus, but it's not actually a bus. So the algorithm can also make mistakes. This is not a 100% correct retrieval engine. So now let me get into a few applications of it, of the video retrieval. So we